Hello everyone, welcome. Can you hear me? Can you hear me?
Yes, we can.
Oh, okay, thank you. Just we're waiting 1 minute, then let's start. Okay, so we'll start this session. So let me share my screen. Okay, can you see my screen? Is it visible? Okay, so basically today should I discuss about that machine learning. So how we can easily apply the machine learning model on Google Earth Engine and classify the different types of land use land cover classification. How we can easily apply the supervised or unsupervised classification. We also discuss about that, as well as how we can easily apply the different types of classifier. Classifier mainly algorithm. How we can easily apply the different types of algorithm, such as random forest, then cart, support vector machine, or minimum distance. So this type of classifier, how we can easily apply, and then how we can easily make the land use land cover classification map. We also discuss about that, and how to check land use land cover accuracy. Okay, so kappa accuracy, producer accuracy, consumer accuracy, or accuracy, we also discuss about that, and calculate the land use land cover classes area, how we can easily calculate, we also discuss, and how to add the legend land use land cover map, and how to export land use land cover map. So let's try to explain all of topic step by step, then I hope we can easily learn about that, how we can easily apply the machine learning on Google Earth Engine. Okay, so let me open my slide. So machine learning in Google Earth Engine. So basically, in this case, in Google Earth Engine, we are use some built-in learning. Okay. So in Google Earth Engine, we already have some model or classifier. So this type of machine learning, we are just simply using here. So it's one kind of built-in model. So just we are use the random forest function or cart function or minimum distance function. So this is one kind of built-in machine learning method in Earth Engine. And using the Earth Engine, we can easily do this type of model, suppose supervised or unsupervised. So basically, machine learning is a branch of artificial intelligence that allows computers to learn from data and make the decision or prediction without being explicitly programmed. So there's a lot of use in the machine learning, but basically we find out the two types of machine learning. First one is the supervised learning, another one is the unsupervised learning, as well as we also use the reinforcement learning. But in this case, I will discuss about that supervised and unsupervised learning. So basically, supervised learning you provide both input and correct output, or you need to the level data when you apply the supervised learning. And unsupervised learning, you not need any kinds of label data, as well as you don't need any kinds of pre-categorized data for the unsupervised classification. But supervised classification, you must need the ground truth data, as well as also need for that your label data. Suppose I want to classify build up, vegetation, or barren land, so I need this type of label: build up, barren land, vegetation. But when you classify unsupervised learning or unsupervised classification, not need any kinds of ground truth data. So let's go ahead and discuss about that all of a step one by one. Then I hope we can easily get that how we can easily apply the different types of classifier. So basically in Google Earth Engine, classifier is known as an algorithm. Okay, so which algorithm I apply on my data set, it's called the classifier. So the algorithm which we implement the classification on a data set is known as a classifier. So basically all of classifier we divide into two types. First one for the binary classifier, another is for the multi-class classifier. Suppose in the binary classifier, if the classification problem has only two possible outcome, then it's called the binary classifier. And multi-class classifier, if a classification problem has more than two outcome, okay, more than two outcome, when you find out, it's called the multi-class classifier. So now we are use different types of algorithm for binary classifier or multi-class classifier, different algorithms. Suppose support vector machine, it worked very well for the binary classifier. Then random forest or cart, so this type of classifier also used for that multi-class classifier. Okay, so binary classifier, basically when you output only for the two possible outcomes, suppose yes or no, male or female, spam or not spam. Or multi-class classifier, more than two. Suppose different types of land use land cover classification, different types of crop, so it's one kind of multi-class classifier. And binary classifier, only possible two possible outcome we find out for the binary classifier. And what's the process to make the land cover classification map in Google Earth Engine? So I will step by step, I will show you the work. So first step is that you need to select your study area. So his area you want to make the land use land cover, just simply import your shapefile for your boundary, which area you want to make the land use land cover. After that, simply choose and filter the image collection. Suppose you choose the Landsat or Sentinel, it totally depend on your research work. So you can simply choose and filter, just simply choose and filter your image collection, and then collecting the training point. So when you apply the supervised learning method, then you must need the collect the training sample. Okay, you must need take the training sample to work. Suppose I want to classify build up, vegetation, barren land, or forest, so you need to take the training sample for each classes. So collecting the training point, and how we can collect the training point, there's a lot of way for collecting the training sample from satellite imagery, as well as if you want you can also use the ground truth data also. Suppose you simply visit your study area, further you simply collect some training sample. So this type of training sample you can also use in the satellite imagery, and further you make the classification. As well as we also use the different types of band combination to make the collect the training sample. Okay, so I'll show you the practically how we can easily work with that. And then merge all of training sample together. So all of training sample simply merge and store in a one variable. After that, selecting the bands. So basically selecting the feature bands. Suppose you select different types of band, so this type of bands work as a feature. Okay, suppose B1, B2, B3, or blue, green, red, near infrared, short wave infrared. So this type of band work as a feature. So this type of feature extract the information for different types of training points. Okay, then make a training data set by sample regions, and this data set we simply split into training and testing. Training data set basically train your model, and testing data set basically check your performance level of your model. So just simply split the data set into training and testing. After that, create the classifier and train the model using training data, and model connecting with your satellite imagery. and then create the classified image, as well as display the result and print contribution metrics for accuracy assessment. So this is the overall process when you make the land use land cover classification map using supervised learning. Just apply this process. Okay, so let's go step by step. I will try to show you that how we can easily make the land use land cover classification map for our study area. So let me open my code editor. So first step is simply import your study area. Suppose I want to import okay, let me choose the one district from Bangladesh, and then we try to make the classification. Okay, just take a variable, suppose ROI.
Can I see the visible?
Okay. Can you see my screen now?
What you are discussing, you cannot see.
Okay, from my side it's okay. I take it. Anyone have this problem?
It's visible.
Yeah, it's also okay, no problem. So kindly refresh, then I hope it will be okay, no problem. Okay. Okay, so now here just I simply import the district total, all of district boundaries. So from here I simply choose my one district, then try to show you the practical example. Okay, so just I simply filter this table, and just I filter how I can filter earth engine dot filter dot equal. So what's equal what? Just I simply find out the attribute table. Yeah, so from this attribute table you can see the column name, which column is stored all of district name. Okay, so basically in this case, this name to this column is stored all of district name in Bangladesh, name to. Okay, this name to column. So just simply copy. And paste here. And I simply put here district name, suppose select. So now let's go, we try to display the study area. And also focus map dot center object. Object is ROI. So now run the. So now this is my study area. Suppose I want to make the land use land cover classification map for this study area. Okay, so this is the first step. So which area you want to make the land use land cover? Just simply import your shapefile. Okay, so now this is my area of boundary. So first step is done. So now second step we try to choose and filter our image collection. So in this case, if you want, you can use here the Landsat, or if you want, you can also use here the Sentinel. Both images are the same process when you make the land use land cover classification map. So in this case, suppose I want to use for Sentinel-2 satellite imagery. So Sentinel-2 is more better resolution than Landsat. But when you work with the historical data analysis, historical land use land cover classification, then you need to use here the Landsat. Okay, Landsat is 30 meter and Sentinel is the 10 or 12 meter. Okay, so but when you work with for present time, not need for the historical data, then try to use the Sentinel-2 satellite imagery. But when you work with the historical data analysis, historical change trend for land use, land cover, then try to use the Landsat satellite imagery. So let's go, we try to work for Sentinel-2 satellite imagery. Just click on the Sentinel. But Landsat or Sentinel, both are the same process for land use, land cover classification. So I want to work for the Sentinel-2 multispectral instrument. And in this imagery, I want to work for the surface reflectance satellite data for make the land use, land cover classification. So this is the satellite imagery we find out. And just same process, just simply filter this satellite image collection for your study area. Just I paste here and then simply filter. Just take a variable name. You can put any name as a variable. I put the name, suppose image. Okay, so now we try to filter this image collection. We already know about that, how we can easily filter. So first one is for the filter bounds function. Filter bounds with your study area, which is ROI, because ROI is stored at this select boundary. Then put here the filter metadata for filtering image properties. I want to use suppose cloud pixel percentage, this properties, just copy and paste here, and then put here less than, I choose suppose less than 1% cloud pixel percentage. After that, when you need the image, so put here the filter date function for that. So I want to create 2025 1st January from 2025. This last time you can see this is the 0502. Okay. 0502. Okay, so now let's check how much image is available for this condition. Just use here the image and put here the size function. So now it's computing how many images are available for this condition. So we find out that 22. Okay, this 22 imagery, if you want to check all of images a specific time and work with for the single imagery, just print the image. So now we find out that all of images information. Okay, all of image acquisition time, all of information you can easily find out from here. Okay, all of single imagery. So you can see from the feature we find out that all of images information. Suppose I want to work for this image, just simply click on here and then you can simply copy the ID. Okay, copy the ID, then we are just choose the single date imagery. Okay, this imagery acquisition date you can see, click on the properties. So here we find out that all of information about this imagery. February 21. Okay, 21 February, or you can also check it from here also for the image ID. Yeah, 21 February 2025. Okay, so this is the acquisition time. Just copy this ID, then you can also work with this imagery. Okay, but in this case I want to apply suppose median composite. Sometime for different types of analysis we also need the single date imagery. Suppose for single date imagery I want to check what the condition of the land use, land cover, so then we can just use it. But in this case I take all of images, suppose 22 images, middle pixel value, and create a composite. So for that just use here the median and then clip with my study area, clip with the study area which is ROI shapefile. So now run the code. So now it create the median composite using total 22 images. So this image I want to visualize. So for that just map.add layer and call the image, run the code. So we can find out this type of imagery. So now we try to put here suppose red, green and blue. So I guess it show very long value. And if you check the image information, they already provide the scale. So you can see it already provide the scale. So all of bands are the same scale, B1, B2, mainly aerosol, blue, green, red. So all of bands are the same scale. So now this scale you just simply multiply. Okay, simply copy and multiply. After the median, just simply multiply. Okay, so now run the code. So now it reprojected the scale value, all of bands. So now we try to apply. Suppose red, green, and blue. Stressing keep suppose 98% and apply. So now you find out this type of imagery for this area. So just import and copy this vision parameter and paste after the image and put the layer name. Suppose it's a imagery. Okay. So now this is my imagery. So this imagery I want to classify. Okay, and classify the different types of classes. Okay, so this is second step is done. So now we talk about the third step. So in the third step, basically we need to take the training sample when you apply the supervised. So first of all, I talk about the supervised, then I show you the unsupervised. So both of learning, how we can easily apply, I will show you that. So now third step. Training sample. Okay, so which class you want to classify, just simply collect the training sample. Okay, so this collecting training sample we can collect different way. Suppose you simply visit the study area and then take some latitude or longitude value for the specific classes, then you can easily import this type of latitude longitude value in Google Earth Engine, and then further this type of point you just use as a training sample. Okay, so in the fifth number class I discussed about that how we can easily upload the CSV file, basically a specific latitude longitude value, and this type of latitude longitude value when you upload it, then it work as a point feature. So you find out the some point feature. So same procedure also apply when you upload some latitude longitude value for a specific classes. Suppose I create a file for suppose PADI. So all of PADI training sample I just store it in a CSV file. Suppose all of jute training sample just store it in a CSV file. So all of sugarcane training sample just store it in a different CSV file. Then simply one by one upload it. Okay, then it's the one way. Another way is that we also use the different types of band combination, and then we identify different types of feature from satellite imagery. So just use the different types of band combination and identify different types of feature from satellite imagery. So now this band combination called the RGB, mainly natural color, or natural color basically vegetation, we find out this type of green color. Okay, as well as we can identify this type of place, we find out the barren land, necessarily we find out this type of band combination. Not only for that, if you want you can also use the another band combination. Suppose click on here and apply suppose near infrared band, then put here the red band and blue stressing 98% and apply. So now we find out this type of band combination. So this band combination when you apply, always we find out the water body as a black color. You can see water body show as a dark color or black color. So this type of black color display as a water body, and vegetation show as a red color. Okay, vegetation show as a red color we find out, as well as this type of gray color indicating about the barren land we also find out. So always, so for any study area when we apply this type of band combination, near infrared red and blue, then we find out this type of visualization. So water body show as a black color or dark color, then barren land show this type of gray color, and vegetation show as a red color. Always we find out. Not only for that, if you want you can also apply the another one. Suppose short wave infrared one, uh, then near infrared and blue, then apply and also apply. So now we also find out this type of visualization. So in this visualization, we can easily identify for the vegetation or agricultural land, okay, or barren land, okay, as well as water body. This type of black color indicating the water body, we can easily identify from here. So also zoom more. So here you can see we find out this type of color. So basically it's the agricultural land, and also you can see this type of vegetation. Okay, it's indicating about the normal vegetation or trees. But when you see this type of color, this type of color indicating about that agricultural land or crop land. So from here we can also identify this type of place is the crop land, also this place. But you can see this type of place is vegetation. Okay, also you can check. Suppose you can see this is the vegetation, normal vegetation. It can be trees or other types of vegetation. And you can see the water body show as a black color, dark color. And this type of things is stored about that barren land or fallow land about. Okay, so this is the way. So let's go try to take the training sample from the satellite imagery. So first of all, suppose I want to classify it for water body. We can easily identify the water body from this satellite imagery. So just click on the marker. If you want, you can also take the polygon and rectangle and take this type of polygon. But it's more better try to use the point feature. We try to apply. Just click on the point, and you can see it's added the geometry. So now click on the setting layer properties and put the name. So I put the name, so it's a water. You can put any name. Then import as feature collection. Okay, import as feature collection. And property, so I add the property name, suppose class, and set the value for 0 mainly it's my level. Okay, so I set the level 0 means water body training samples. So then okay, so now take the some training sample. Okay, basically this type of black color indicating about the water body. Just simply take.
Have you muted your microphone? Because I can't hear you.
Okay, can you hear me?
No, yes.
Okay, just I take the training sample now. Okay, and how much training sample? So you try to put more than 30 first time for train your model. So I put suppose 39. Okay, so first step take the 30, but further we face the any problem, we find out the low accuracy, then we try to increasing or decreasing the training sample again. Okay, suppose water is done, then I take the another one. I put here for training sample for suppose vegetation. So feature collection, put the property name, suppose class, and put the value for suppose 1. Okay, so vegetation we consider the 1. We just take the green pixel. Okay, so now I just make the all of vegetation together. Suppose cropland, agricultural land, or forest. Just make a one class for vegetation. Okay, it's including all of vegetation for cropland, then forest and trees, or agricultural land.
What is the dark color on the green spot?
Yes, so this type of place is the agricultural land. Okay, not vegetation
No, no.
or not others.
Some dark points on the green color.
This one,
What is that?
this one.
No. Small one. Small.
This, yeah, it's a water
Small.
body. It's
Yeah,
water,
yes.
water. So it's the water body.
Small
So
one.
yeah, this is a small water body. So this is the water body. Black color, it's a water body.
Okay, good.
Yeah.
Thank you.
Yeah. This is the water body. A small water reservoir.
What if a lake is eutrophicated? So in that case also it will show green color.
Which one?
If a lake is eutrophicated, like if the eutrophication is there in the lake, then it will show green color only in the satellite image.
Okay, then we find out the some phytoplankton, this type of plants also. Okay, so green phytoplankton. So then this type of water body is also show about that green color we find out. Okay, in the water body. Okay, so let's be take that to the another training sample. Suppose for Berlin. Feature collection property. I put the same property name always and set the value for 2. Get 2 means Berlin. We set the level for 2. So now this type of color. Or you also check the multiple band combination try to put and also check more. Okay. Otherwise it's some also misclassification. Okay, so now we put the another class for the build up. Okay, so in this case, build up we find out for this area, but now it's not more better visualization. So we try to put the another one. Suppose I put here the natural color. Suppose red, then green and blue. And up. Okay. So in the build up, we find out this type of pixel. Because natural color it visualize the more better for build up area than others visualization. So now you can easily find out this type of place have the build up or settlement. So just take the new layer and put here it's a build up. Property, put suppose class and set the value for 3. Okay, so you put the you can say 0, then 1, 2, 3. So now build up. So now select the build up and then take this type of training sample. Okay, it's also road. We consider the all of building roads together. Okay, done. Okay, suppose this is the third step is done for taking the training sample. So now fourth step, in the fourth step, we need to merge all of training sample together. Okay, so you can see it already added the water, vegetation, barrier and build up. So simply merge all of training sample together. So now take a variable. Suppose I put the variable name, suppose sample. So now just simply merge all of training sample together. So first one is the water, merge with vegetation, then merge with bare land, then merge build up. So now we just merge all of training sample. If you check how much training sample we take, so simply put here the samples and run it. So now you find out total 195 training sample, and all of training sample, if you check the feature, we already set the level. Suppose click on here, check the properties, we find out the level is 1. So this training sample I used to take the training sample for vegetation because I said the vegetation value is 1. Okay, so now our level is ready. So you can say our level is ready. So this is the level 2. So this training sample I collect for barren land because you can see barren land value is 2. So all of training sample we set the level. So now we need to set the feature. Okay, so I set the feature. So in the feature, if you I show you the practical example. So let me open the Excel file. Suppose in this case I have some value, suppose b1, suppose b2. So this is my band name. Then suppose b2, then b3, b4, b5, suppose b6, b7, b8. Okay, or b8a for Sentinel, then b11, or suppose b 12. Okay, suppose I have this type of uh, feature or this type of value I have. Suppose I have some value and also another column it is stored, suppose level. Suppose I have level 0, some level I have 0 1 2 3, this type of level, and then this is my feature. Okay, this type of feature b1, b2, b3. So this is the property. So this is the property. So based on this property I need to classify my level. Okay, suppose I have b1 value suppose 0.3, I put the random value. Suppose this value suppose 0.6 randomly, or 0.7. So look like that, I have this type of value for different level. Okay, so now this is my properties, this type of properties. I just extract the information. Okay, I extract the information, all of information. Suppose b1, b2, b3, this type of band information I just extract for all of level. Okay, then apply the machine learning and classify it. So let's go try to make this type of things and then extract the information. So now I already set the level. You can say I already set the 39 points for water, 49 points for the vegetation, 36 for barren land, 71 for build up. So now I just set the feature. Suppose which types of band I want to use, and then extract the information for all of points. So in this case total 195 points. So 195 points I extract the some information, or I extract the some property or value. So let's go for that. I just take a variable, suppose bands. So in this variable I just make a list all of band, which band information I extract. So in this case if you check, we find out this type of band b1, b2, b3, b4, b5, b6, b7. So if you want you can simply take the band only for the 10 meters and 20 meters. So I just choose 10 meters band and 20 meters band. So I choose suppose b2, b3, b4, then b5, b6, b7, then b8, b8a, then b11, b12. Okay, just I choose only for the 10 and 20 meters band in my use this type of band to extract the information from all of training sample, total 195 training sample. So let's go try to put here the b2, then b3, b4, b5, b6, b7, b8, b8a, b10, no, b11 and b12. So b11 and b12. So now I just use this type of bands as a feature. Okay, so it extract the information for all of training sample, extract the information from all of bands. Not only for that, further we will discuss about that how I can add the some external band. Suppose I create the ndvi. So when I add the ndvi, what happened? So all of training sample also extract the information from ndvi pixel will extract. Then suppose if I put here the NDWI, so then what happened? Then all of training sample also extract the information from NDWI. Suppose when I put here the EVI, then all of training sample also extract the information from EVI, and then create the strong data set. Then I can easily distinguish the different types of classes. So further let's discuss about that, how we can easily add the some external band, and it's very helpful to increase your accuracy. Okay, so let's go to just keep this type of band. So I want to extract all of bands value for all of point training sample point. So for that, just I take a variable, suppose put the variable name, suppose training, and I already have a image. So this is my image, it stored my image. So just I copy and then put here the select function, select, I select all of bands. So all of bands already stored in a variable, bands variable, just copy and paste here. Okay, then just use a function. We already know about the function, we already use lot of time. This function called the sample regions. Okay, sample regions. So in the sample regions you can see, so it extract the information from a collection. So now I have total 195 training points. Okay, so I want to use the sample regions function and extract the information. So let's go try to put this function in here. So just click on here, it will be imported. So now collection, so I already make the collection. This collection mainly 195 training points or training points, it is stored in the samples variable. Just copy and paste here. Okay, it's done. So now properties, so all of sample I already set a properties. This property name is the class. Okay, I keep the same property name. So this property mentioned in here, just put here this property is class. Then scale, I keep the scale 10 meter and extract the information from this 10 meters. Then it's not need, just I remove. So now if I just print the training, so now all of training sample also extract the information for different types of band, basically B2, B3, B4, B5, B6, all of band, which I make the list, it extract the information for each training sample.
So all samples are scale 10, huh?
Yes.
Whatever we
Yeah. Basically, it's depend on the your band's pixel size. Okay, for this. So in this case, 10 meter and 20 meter band I use, but I want to extract the information 10 meters. 10 meters basically 100 square meter area I consider, and extract the information for each point.
Thank you.
So now if you check the features, so you can see all of training sample, it extract the properties. So you can see for the class 0, for this point it extract the information B11, B12, B2, B3. So all of training sample, all of, so it's one kind of feature or property. So we find out. So if you check it, so this is another. So all of training sample extract this type of information, and this is my data set. Okay, so this is my data set. So further this data set I want to use and train my model, and further we just make the classification as well as also check the accuracy or other things. Okay, so this is the way to create, extract the information. Not only for that, further you also add some external band, how we can easily use, and then extract the information. Let's discuss about that. Yes, any question please? Yeah.
How do we select the band? I fail to understand that. Like we have not taken all the maths.
Okay, so basically, first of all, we just use all of bands which have satellite imagery, but further different types of classification, we need to add the different types of other external band. Suppose when you work with the crop types classification, then we need to add some crop type related band. Suppose NDVI, EVI, SABI, then we can easily distinguish the different types of crop. Suppose I want to classify different types of crop. Then basically vegetation, this type of band if you want to use, then it's very difficult to distinguish the vegetation, different types of vegetation. So for that we also need to add some more other external band. Suppose you need to use, suppose NDVI, normalized difference vegetation index. Then suppose you use at the EVI, enhanced vegetation index. Then you need to use for soil adjusted vegetation index or SAVI. So then you need to add some external band related to the vegetation, and when you are use this type of index, then we can easily distinguish, suppose different types of crop. Suppose this is the sugar cane, this is the rice, this is the jute. We can easily distinguish when you are add the different types of different types of vegetation related index. Suppose sometime you also face the problem. This problem is that sometime build up and barren land we find out the similar, it just misclassification. Okay, because it's just similar spectral value is almost same for the build up and barren land. So for that we need to add some index related to the build up, okay, and also barren land. Suppose we are just using at the NDBI, normalized difference build up index, as well as we also use at the PSI mainly barren soil index. So when you are at this type of external band, then it easily distinguish this is the build up, this is the barren land. Okay, and it extract the information. This type of training sample also extract the information for NDVI and BSI. Okay, but first time we are just select some our bands which is available in the satellite imagery. Just simply choose and then just run the model. Further check the accuracy. When you are then it also depend on your different types of land use land cover classification, which types of band you want to add, external band. Okay, so I'll also show you this process also, how we can easily add the different types of external band. And when you are add this type of band, your accuracy is also increased.
So the adding the external band, I understood. So how do you select it B2, B3, B4, B5, or like these things, 5 or B1? What?
Oh, okay, so I choose for that I choose the resolution. So in this case I choose the information only for the 10 meters and 20 meters. Okay, I skip the 60 meters pixel size band. Okay,
Then in the scale you have put 10 meter. So will it consider 20 meter automatically, or it will exclude it?
it also excluded.
Okay.
Yeah, yeah, yes.
So then why have you selected 20 meter bands?
Okay, 20 meter in this case basically we just extract the information. So if you want you can also take only for the 10 meters, there is no problem, or also take only for the 20 meters, or if you just make the mix also there is no problem. Okay, so this type of bands basically we are just extract the information. Okay, in this case we extract the information from the blue, green, red. Okay, or red is one, or near infrared, so it extract the information. So if you check the pixel value, so we find out the different pixel. You can see we find out that this pixel value, this pixel, okay, this is the value for this training sample we find out. Okay, also if you check another point, so we find out this type of value for the different band value we find out in here for this. And when you add the more band, then it also extract the information from this type of band. But first time in this case we are just use the satellite imagery. So for the satellite imagery, so it's the combination different types of bands. So in this case we are just Landsat, there is no problem because Landsat all of bands are the 30 meter resolution we find out. So that there is no need to choose, but in this case we are just keep only for the 10 and 20 meters. Okay, this type of band, because we create the high resolution land use land cover mapping. So just skip the 60 meter bands. Okay, just keep only for the 10 and 20 meters. Okay, okay, so this is the training we find out in here. So now we are just okay, after creating the data set, now we talk about the fifth step. In the fifth step, just spill the data. Okay, so spill the data basically, suppose it's different, suppose 70% data sometime we also use for training, and rest of the 30% data for testing. Okay, sometimes if you want, you can also check some other paper, they also use at the 80% data for training, and rest of 20% data used for testing. Okay, so in this case, suppose I keep the 80% data for training and 20% data for testing, or 70% data or 30% data, there is no problem, we'll choose any one. So let's go try to use 80% data for training and 20% data for testing. Okay, so first of all, just take a variable. Suppose I put here the spilled. Suppose I keep 70% data for training and 30% for testing. Okay, so for that, put at the 0.7, and these things we do randomly. Okay, so for that, take a variable. I put the variable name, suppose dataset. Okay, you can put any name, dataset, and this variable is stored all of training information. Just a copy. So I want to distribute the data randomly. So for that, just use at the random column function. So now this data randomly distributed. If you want, you can also mention here the random, and then take a variable, suppose is spilled 0.7. So we are just roughly 70% for training and 30% testing. Okay, so take a variable